I'm Tahiya Salam. I'm a graduate student here at the University of Pennsylvania, and I work in GRASP with Dr. Anisha. So today we did a demo using a team of robots, and the goal of this demo was to get a team of robots to try and track the environment. So they all have little bits of information about the environment that's immediately around them. And what they do is they share this information with other robots to try and build an overview of what the environment looks like. So this is really important for things like trying to track oil spills, algae blooms in the water. And so most of our applications are really focused towards ocean and ocean exploration. So the map is an overview of what the environment looks like, and depending on where the robots are in the environment currently, the map might need to change. So there could be locations in the environment where the robots need to collect more information, or there could be places in the environment where it's changing really quickly. So we want to be able to track how quickly these changes are happening based on where it is currently and using the map to update where it should go next. This research, like the research that I do, is really looking at this robotics question of how we can map environments and abstracting that away to how can we just map things that vary in time. And things that vary in time in physics are called dynamical systems. And so a lot of the work we do is at this intersection of how we can use data to better understand these really general systems. And I think that's really powerful because that having like a really general framework like that allows us to apply it to so many different problems and so many different domains that aren't really restricted to, hey, I'm this robot trying to map this environment. Instead, it's like, how can we just predict things that are varying in time, which are like really all around us? The other reason why it's really interesting from a robotics perspective is because the ocean is really complicated. So you don't have Wi-Fi in the ocean. You have these really turbulent conditions from the currents that are there. You can't really see all that well, so cameras don't work all that well underwater. You have issues with water leaking into electronics, which if you spilled coffee on your laptop, you know that that's not a good thing. And so there are all of these nuances that come to using robotics in the ocean that make it technically a really interesting problem to study. Our research really focuses on this interplay between the environment and the robots themselves. So even though we really focus on this challenging underwater or oceanic environment, a lot of these techniques can be generalized to, say, ground vehicles or aerial vehicles, where you can have, instead of currents, you might have the wind, or instead of the ocean, you might be working on the surface of the road. And so by developing these technologies in really challenging environments, we can extrapolate those ideas and apply it to different types of robots that may also still have some of those challenging elements. Ocean exploration is important for two really big reasons. The first reason is that it has a lot of inherent scientific worth. The ocean is really the last part of the Earth that hasn't been explored yet. So most of the deep sea, most of the oceanic environments really haven't been touched by humans. We don't know what's there, and for climate change and for scientific discovery, it's really important to try and explore this last frontier. I went to the University of Virginia for undergrad, and I majored in computer science and math. I don't feel like I had a really defining moment when I knew that I wanted to become an engineer. I feel like it was kind of an accident. I started learning more and more about engineering and decided that it was something that I wanted to do. I really liked the aspect of being able to use technology to help people, and I feel like that's really what drew me to engineering. So this is one of our boats that we build in-house. It comes with a cap and a hull that are 3D printed. And each of these boats has a unique marker. So these 3 dots are used in our tracking system to determine which boat is actually in what location. So if the tracker sees a triangle, it knows that it belongs to the blue boat. If it sees this weird other pattern, it knows that it belongs to this green boat. Here in the tracking system, we can tell where exactly the robot is in the tank based on all of these cameras that we have set up. So all of these cameras look at the markers of the robots and say the robot is in the center of the tank or it's towards the edge of the tank. The robots have no clue where exactly they are in the environment, so they have no sense of location. Penn is really special for several reasons. One is the Grasp Lab. I feel like it has a really collaborative environment, which really appealed to me. And the other big one is that it's in Philadelphia, and I love Philadelphia. It's close to home for me. And so the combination of those 2 things made it a really appealing place for me to work. If you are in high school and you're interested in robotics, it's always good to take your math and science classes. If you have a robotics program or a computer science club in your high school, it would be awesome to get involved with clubs or extracurricular activities that focus on robotics and engineering. There are also summer programs, like the summer programs we have here at Penn. Shameless plug, I am director of a summer program here at Penn called AI for All, where we have a summer camp that's targeted towards Philadelphia area high schoolers, and it's awesome. If you have the opportunity to apply, you definitely should. The other big piece of advice that I would have is just try a lot of things, learn about a lot of different things, because robotics is really interdisciplinary. And so just being able to put together pieces from different fields is really the essence of robotics. And in that sense, it's good to just be well-rounded and learn about the things that interest you. So here in the boat, we have a little mini computer that holds all of the information that makes this robot an actual robot. So we have this chip that allows the robot to communicate with other robots. We have a mini computer that allows it to sense and understand motor commands. And what the motor commands do is they take information from the computer and they run it to the motors and tell them to spin. So you can see here we have little propellers, and they either spin clockwise or counterclockwise. And when we tell the motors to run a certain way, they can move clockwise to turn this way, or they can move counterclockwise to turn this way, or they can both move to go forward. We also have this little battery that attaches to the boat, and this battery is actually what gives the robot power to either run the motors or make computations on board. So we use a little microcontroller that we order online, and then we solder all of the components onto the microcontroller. This is an XP, and this XP is the communication chip that allows us to communicate with this little antenna. If I had any advice for either people of color or people who identify as women that are just getting started in STEM or interested in STEM, it would be really to foster a network of people that support and uplift you. Having these identities in STEM can be really challenging, And there's no sugarcoating it. It's just how it is, and it is so helpful and critical to foster a sense of belonging with your community, people that uplift you and support you and help you when you need it the most. But I've interacted with high schoolers, and I don't know if I have any advice for them. They are way smarter than I was in high school and have such a sense of what it means to be a good steward of the world and such a sense of how their lives interact with other people's lives, and are just so much better in every sense of the word than my generation or older generations. And I have so much hope for them, and I feel like they got it. This isn't a piece of advice, but I want people to know that they can do it, and I believe in them, and that I'm supporting them along the way.